Welcome to David Alexander Maths Tuition. This is chapter 4C on reciprocal graphs. So not many questions to answer in the book on reciprocal graphs. It's a really short chapter. Now the key thing, just learn what some of these graphs look like. So 1 over x, you need to remember that 1 over x looks like that. There's no x-intercepts, there are no y-intercepts, so you can never be asked to show where the graphs or where the curves cross the axes because they don't. Now, if this is the graph of 1 over x, let me just do a sketch of 2 over x. You know, I can make them look almost identical. I've not written any values on here or anything, so they look the same. But if I were to draw them together, if this is 1 over x, then 2 over x would just be slightly further away from the origin. So these are sort of fairly lame sketches. So this blue line here, this is 1 over x. So you can see the distance from the origin is less than the distance of the red line, which is 2 over x. So 3 over x, 4 over x, 5 over x. Again, we would be seeing a bit of a gap. There would just be just a greater distance from the origin. So make sure you know what 1 over x looks like, and make sure you know that 1 over x is closer to the origin than 2 over x, which is closer to the origin than 10 over x, which is closer to the origin than 100 over x, etc. So if 1 over x looks like this, then negative 1 or minus 1 over x is the opposite, like so. So this is minus 1 over x. This could also be minus 2 over x, but if I were to draw the two of them together, then they would be, again, some fairly shocking drawings here, but we can see that minus 1 over x is closer to the origin than minus 2 over x, as you can see here. So this is minus 1 over x, and the red line, that is minus 2 over x. So the blue one, pretty close to the origin, well, closer to the origin than the minus 2 over x. So the greater the number here, then the further it is from the origin. Okay, so what about 1 over x squared? So 1 over x looks like this, and 1 over x squared, remember when we square a negative we get a positive, so 1 over x squared is reflected in the y-axis. The y-axis is a line of symmetry. So if this is 1 over x squared, then 4 over x squared is pretty similar. In fact, this could be the sketch on its own of 4 over x squared, but if I were to draw 1 over x squared and 4 over x squared on the same axes, then 4 over x squared would, again, it would just be further away from the origin. Okay, so this blue line, that is 1 over x squared, and the red one, that is 4 over x squared. Again, there are no x-intercepts or y-intercepts, but here we can see that the x-axis is an asymptote, so it will get closer and closer to the x-axis, but will never touch it. Okay, so hopefully we know this is 1 over x. This is 1 over x squared, so negative 1 over x squared is a reflection of this in the x-axis, so it will look like so. Again, there are no y or x-intercepts. The x-axis is an asymptote, the y-axis is also an asymptote, so it will get closer and closer to the x-axis as the x values get lower and also higher on the right hand side. And as I said, the y-axis is also an asymptote, so as we go down here, this will get closer and closer, but will never touch the line. So let me just draw it again because it's got a bit messy. So this is minus 1 over x squared. That could also be minus 3 over x squared, but if I were to draw them, both of them on the same set of axes, then minus 3 over x squared would just be further away from the origin, as you can see in this sketch here. So the blue one, this is minus 1 over x squared, and the red one, further from the origin, is minus 3 over x squared. And again, we can see that the x-axis is an asymptote. We can see we're getting really, really close. It almost looks like it's almost touching. It will never touch. Y-axis is not so obviously an asymptote at this stage, but as we go further down the y-axis, you'll see the blue and the red lines get closer and closer, but they will never touch.